Able to see the full screen? Yeah.
Yes, sir.
Okay. Mr. Rinamul, can you share? Let me, what is the purpose of relay according to you, Mr. Rinamul?
Relay sense the fault,
Relay?
and based on the relay sense the fault, and then send the signal to breaker to trip the trip relay.
Okay, trip relay. I will catch hold of this word trip. Okay. And our Pinaki ji is also having a lot of experience. He is from a previously ABB also. So what is when you come across this word trip, what does it mean?
Trip means it is the opening of the arms of the circuit breaker and isolating isolating the faulty circuit, or just the isolation of that circuit is called in tripping.
Recording in progress.
Okay, isolating.
Isolation of the circuit by the opening of the contacts of the circuit breaker is called trip.
Okay. So when you say isolating, okay, you told isolating of a circuit, yeah? Right? Now we have
Yes, sir.
our Mr. Gaurav. He will tell Gauravji.
Yes, sir.
Gauravji, you are using. You are a manufacturer of switchgear, right?
Yes, sir.
Yeah. So when you say isolation of a circuit, okay, I will ask about that next. So, you all have come across single line diagram? Single line diagram is very common. Okay. Now let us see this single line diagram. So I will start from the basics. Though you all are actually having very good knowledge, still I am going to start from the basics. Okay. So don't feel bad that I'm starting from basics, right?
Right.
This is a single line diagram, and what is a single line diagram? You all know single line diagram is the word itself is there, single line. There is only one line, that is why it is single line diagram. So just like our piping guys have piping diagram, civil guys have layout, structural diagrams, just like that we have single line diagram. One very important thing in single line diagram is to show all the breakers and also show the current transformer and the relay. So this is incomplete protection SLD. If you see this SLD, I should have shown a CT here. Okay, I've shown a CT here and a breaker, this one here, relay. I should have shown a CT and a relay here also. Gauravji,
Yes, sir.
what is this 51N? Are you able to see here 51N?
Yes, sir.
Any idea what is that 51N?
Even N is
Pardon, sir?
it is a number for a protection relay. I believe overcurrent plus
Correct, sir.
overcurrent relay.
Absolutely correct, sir. It is a number for a relay. Just like all the relays, we are given a number, ANSI number. So let us brush up some of the ANSI numbers quickly. Like you start from 27 under voltage relay, then we go to 32. 32 is the reverse power relay. What is 49? Thermal overload relay, right? And 50 is instantaneous relay, 51 is over current relay. What is directional relay? Device number 67 mostly. Then differential relay is 87, right?
Yes.
Yeah, and under frequency, over frequency, over voltage is 59. So like this, we have
Yes.
all device numbers. Now, in this relay coordination, you are mainly dealing with 51. Okay. Relay 50 also will be there when we plot the curves, but mainly we are dealing with 51. Okay. And what is this N?
Neutral.
Neutral.
Naveen Kumar?
Sir,
What is this N in 51?
it's a representation of a ground fault, sir, like
Ground fault.
neutral.
Correct. So we have 51 means IDMT characteristic. You all know that. N means ground fault. So there are two types of fault, right? Base fault and ground fault. So this N is the ground fault. Now for this, the CT connection method also will be different. Okay, I'll not go to that. Now, 51N also we have to sometime coordinate. Like for example, if my fault current 50 overcurrent fault and earth fault are same, then I need not do separate coordination. But if my overcurrent fault is one value and earth fault is one value, then we have to go for separate coordination. Okay. Now, our Vijay ji, when do you think this earth fault current will be different?
I think see when we consider this three-phase symmetrical fault, the three symmetrical fault is like you have all the three phases involved, lines involved, and earth fault is you will have a single phase and neutral connected, and there is an earth fault there. So sometimes we have, most of the times I think we design for earth fault to ensure that earth loop impedance values that helps in tripping the circuit breakers.
Okay. We all have come across the high resistance, low resistance, grounding.
Mostly for generators.
Yeah, generators. Also, if you, for example, you see a medium voltage system.
Okay.
There also are 6.6 kV motors. When we use them, there also you will see that resistance earthing is used. And when resistance earthing is used, the fault current will be less. Let's say the fault current is, see here the phase fault is 6.3 kA. The ground fault may be, let's say 1000 amps. In that case, we have to go for separate coordination. Okay. Okay. Now, purpose of the relay, already you guys only have told to provide a trip signal. Relay will give trip signal for the breaker, right? And how does the relay sense the fault? Through the current transfer. Okay. when there is a fault, the current flowing in the line is the primary current. It is a secondary current in the CT which goes to the relay. So when you plot your curves later on, I will explain you that it is, but we are plotting the primary curve. Okay. So in a switchgear, we have this strip coil, closing coil, all these coils. All these also take time. Gauravji,
Yes, sir.
you are making the switch gears. So your switch gear has to open a circuit breaker. You are making schematics. You are having a trip coil, and you have a small this one, right?
Yes, sir.
One contact will close, and then the trip coil will energize, right?
Yes.
And after the trip coil energize, it will open one more latch in the breaker. How long all this takes place? Any idea?
Depending upon manufacturer to manufacturer, they have different. I work majorly in the low voltage segment. So normally the opening times are in the range of say 40 to 80 milliseconds.
Okay.
The duration.
Okay. Okay, Ruchi. So when there is a fault, the time the fault takes place, let's say the fault took place, till this breaker opens, it takes some time. We will talk about that also later. Okay. And very important thing for a relay coordination guy, please go through the schematics. Whenever you are doing any relay coordination job, ask for the schematics, go through that also. Okay. That gives you an idea about this time also. So I move to the next slide. Able to see the second slide, selectivity.
Yes.
Yes.
Yeah. Okay. Please tell me. Hold on. Krishna Kumar ji.
Yes, sir.
What do you understand by the word selectivity?
Sir, zone that CT and relay can protect.
Yes. So basically, if there is a fault, for example, if there is a fault here, you can see this fault, this one. Are you able to see this red dot?
Yes, sir.
Yes, sir.
If there is a fault here, this breaker has to open, right? And if there is a fault here, this breaker has to open. Suppose for this fault, or if many breakers open, then we say there is no selectivity, right?
Sir, just one question.
Yes.
That IF 6.3 KA, the very first fault that we have, if
Yeah.
that happens, then that 630 ampere VCB need not trip, right? It's the breaker before the transformer that should trip. That's not shown in the schematic.
Sir, actually, if you see, my CT is here.
Okay.
I am putting in the transformer, no, in this transformer, I will put a CT here. See, you are correct. See, this breaker, the upstream breaker will trip. You are absolutely right. And after the upstream breaker trip, I can trip this breaker also. Some people will go for this interlocking. But to isolate the fault, you are correct. For this fault, I have to trip this. But since there are motors here, I have to trip this also. Clear?
Yes, sir. Okay. Clear.
Fault is
So,
this 6.3 KA, 5 kiloamps maybe will be coming from this side. Another 1 KA will be coming from this side.
Okay, because of motor inertia. Okay, sir, understood.
So we will take one case where we will coordinate the secondary side of a transformer with primary. We can do that also. We will start see, next class. We will start taking up more different cases. Then we will go more deep into it. Okay, sir.
Excuse me, sir.
Yes, sir.
Sir, in case of motor circuit, the CT should be placed before breaker, and in case of feeder, CT should be placed after breaker. Am I right?
In case of breaker,
No, no. For feeder, 630 ampere VCB.
okay,
Yeah, yeah. CT should be placed after breaker,
yeah.
and for the motor circuit, um, yeah, CT should be placed before breaker. What about the PT?
What about?
What about the PT location?
Actually, here PT will be the bus bar. PT,
Bus PT.
yeah, PT, because see, actually all these voltages are same, no? So PT will be, see, when you are going to use PT, one is for your under voltage relay and for your if there is any reverse power relay, you will use PT signal. And that PT, we have a bus PT now. We have one separate chamber. Na? In your switchgear diagrams, you can see there is one separate chamber for the bus PT. So that PT we will use. So each feeder will not have PT. One bus PT we will have. So that one we can use. Okay.
Okay.
Okay. So see this selectivity, you are clear. Now let's go to backup protection. One more very important point is backup protection. See, if there is a fault here, this breaker has to trip, right? You are able to see this. Now, if this breaker does not trip, Pinaki ji, can you tell me under what circumstance a breaker will not trip?
There can be a jam in the motor, in the mechanism, in the circuit breaker opening mechanism. There can be a jam. That is one of the most causes, if leading causes of a circuit breaker failing to open.
Okay. Okay. So let's say the breaker fails to open. If this breaker fails to open, then this breaker has to open. That is the incomer breaker. So if incomer breaker opens, all these feeders will lose the power. But we can't help it. There is a fault. We don't want a fire. We don't want accident. So we have to lose the power. So that is backup protection. Backup for this is the incomer. Okay. Now, like our friend says, if the breaker will fail to open due to mechanical reasons, and very rare relay will fail, but in big switchyard, other places, CT failures also are there because they are big cities or oil field, those cities. But here, let's say in 11 kV switchgear, 6.6 kV switchgear, 415 volt switchgear, chance of CT failure is very less. Okay. So here one main reason is the breaker failure. Also, your switchgear gets DC voltage, right? What is the DC voltage, Gaurav ji, switchgear?
I believe it is normally sometimes it is 24-volt DC or 220-volt DC.
Okay, 24 is there. Some people say 110-volt DC is there.
20.
220-volt DC is there. Yes. Now this DC for the switchgear comes from a battery and battery charger. Two redundant source we are giving. But if this one fails, then also your breaker may fail to trip. Like this, there are number. Okay, a small. Just make a list of. If possible, please share that WhatsApp group. Each of you just note down what are the different causes of breaker uh, failure to trip. Why I am asking you this is related to the time. We are giving a time coordination margin. So please note down this question and post your some list of answers. Why the circuit breaker fails to trip? Okay. Now, okay. Now, able to see this slide? Current coordination. Yeah. Okay. What I will do, I will stop the sharing here. We will log out and log in again so that the timings for each video is less. Otherwise, the video will become very big. Okay, sir.
Okay.
Yeah. Just take 2 minutes break. I will start again. Smart.